Hello and welcome back to section 18. In this video we'll be going over example 4. So last time we looked at Euler's identity and how it allows us to change a cosine or sine function into an exponential function. We're going to do the same thing for example 4, but this time we're going to do it without using those real or imaginary operators that we looked at last time. So the real and imaginary operators make it convenient to rewrite our cosine functions in terms of exponentials. Same with the imaginary operator with sine functions. However, there are cases, or there could just be you're curious if you can do it without, and you can. So you get these functions. So if you remember, we had a cosine omega t plus phi, kind of our generic form. And so we already know we can use a real operator to rewrite that in terms of an exponential, but we can also do it without one. So if you don't like the operators, I don't suggest using this form, but it is valid. So we're going to get a, and then we're going to get e to the j omega t plus phi. So this looks like Euler's right now. Then we're going to get plus e to the negative j omega t plus phi. And so the derivation of this takes a little bit. I'm not going to do it, but you can look it up if you really are curious of where this comes from. So basically you get a over 2 times e to the j omega t plus e to the negative j omega t plus phi. So that's what it looks like if you don't use the real operator. Cosine looks really similar. Sorry, sine. A sine omega t plus phi. So if you had a sine function instead, it looks very similar. A e to the j, oops, that should be a lowercase j, sorry about that, omega t plus phi minus e to the negative j omega t plus phi. And then this is all over an imaginary 2. So that's what they look like. Again, I'm not going to go through the derivation of these, but if you don't want to use real or imaginary operators, these will work as well. They just make I wouldn't suggest using these inside of your first order equations though. They just take longer to deal with because you have to do the exponential twice. But it is possible. So we have v of t equals 20 cosine 3t. I'll just rewrite that here. 20 cosine 3t. We're going to turn it into, well, this is the cosine form, so we're going to turn it into an a e. So this doesn't have a phi, so I'm going to drop that as I write this out. J omega t plus e to the negative j omega t, and we're going to divide all that by 2. So that's what it'll look like, and actually this should be a quantity here. Alright, so our constant in front, a, is 20. So we're going to get 20. I'm just going to move this 2 underneath. We're going to get e to the j, our omega is 3, t plus e to the negative j, 3t. And then we can simplify all this and make it become 10e to the j, 3t plus 10e to the negative j, 3t. Alright, so that's how you would do that if you wanted to turn it into just a pair of exponential functions without a real operator. If you have any questions, feel free to reach out.